Hello and welcome. My name is Flower Grills and this is tutorial number 2 in the Max MSP guide videos. So last video we did this test tone where essentially you just press start and then you turn up the gain object here and you can hear this cycled tilde object make a frequency wave at 1000 Hertz. And that's going to the DAC, the digital to audio converter, which converts the numbers into sound. Now here we've got the second patcher, which we're going to look at this week. So this is an adjustable oscillator. And in fact, here is the tutorial. So this is the max patch that it references, and I've got it open. This is the stuff that I've dragged in myself in order to help explain. So first, we're going to look at the left-hand side over here. And in fact, I'm going to connect my oscilloscope and scope object. I'm going to connect them to this object. I'm going to explain in a second what all of the objects do. Now I'm going to turn on this easy DAC object. This is an easy DAC tilde object. This is the same as the DAC object, except for you don't need to send it a start or stop message. You just have to press the button, and then as you can see, well, you can't see down there, but my audio on button turns orange. Now I'm going to turn the amplitude up. You can see we're getting signal, we're getting sine wave. I can type in 300 and 0.01. And now we have a 300 frequency at 0.01 amplitude. So let me explain what's happening here. Just like last week, this is a sinusoid wavetable oscillator. So it's taking a snapshot, 512 samples of a cosine wave, and then it's repeating it at a hertz, a frequency that you set. So this is the frequency. The left inlet accepts a frequency argument, so whatever you put into here, that's going to be the new frequency. So this is overriding this argument of 1000 here. And then, well, last week in the first tutorial we had this gain object, right? If I pull it up here again, this gain object where you can slide this, and this is essentially a volume fader. Well, in this week, what they've done is essentially give you a more full understanding of how amplitude works in Max, and how the gain object actually works too, because it's a visual representation of this times object. So this is called a times tilde object. You can see it here, and it multiplies two signals together. This is the same as the multiplication object, as you can guess. If you press N and then asterisk, you'll get this object where you can just multiply two numbers, just like in maths. But this is, you can multiply two signals. So the simplest way to attenuate a signal in Max is to multiply it by a different number. Here we're multiplying the signal by 0.01. And it says this here actually. The maximum is 1 and minus 1, right? Because it's a cosine wave. But we can attenuate it to go from minus 0.5 to 0.5, for example. That would be if we multiply it by 0.5. Now it would be from 0.5 to minus 0.5. You can see it there. It's no longer going from 1 to minus 1, it's 0.5 and minus 0.5. So that's the way to attenuate signal. You might as well use the gain object. It's the same thing, really. But this is a way to understand some concepts. So now if you try to, if we turn on the signal and we try to use it like a gain object, you can hear what the tutorial refers to as a zipper noise. What that means is, as you can see here, in this little snapshot, that the sine wave doesn't really look like a sine wave, a pure sine wave anymore, does it? It's got these little ridges here, these sharp points, making it closer and closer to a square wave. And why is that? Well, because when you're changing this amplitude, you're telling the waveform to instantly change position, change its amplitude. So this waveform will naturally, it will get these sharp ridges, and the sharp ridges are what's going to introduce high frequencies. Because if you think about it, a square wave also is very sharp. It's also got many harmonics, and that will sound really like it has a lot of high frequencies. We can try the same with the frequency here. It's not the same sort of zipper noise, but it's actually similar in that it distorts the signal when we just try to change the frequency like that. We can have another look with these here. So again, if we change the amplitude here, you can see down here in the spectroscope that there's some high frequency. And that's because of these instant changes in amplitude, which actually produce an infinite amount of high frequency, but it's limited by your computer by the Nyquist frequency, which is half of your sampling rate, which in my case is 48,000 Hertz. So how do you get rid of this zipper noise? That's what this tutorial is about. So now if we take the spectroscope over to this side, number 2 over there, we can compare what they sound like. I'm going to turn this one down, and here we've got, I'm going to put 300 as well. And let's turn this up, and then let's change the amplitude. And there's no zipper noise. Why is that? Well, you see these line tilde objects. So essentially, these functions similar to the line object, and these are ramp generators. This is the max version instead of the DSP version here. If you feed this a message box like this, and then let's say you put an integer here, and you go this, I think, and then you can set the number here. Yeah, so you can do it with numbers, right? I'm changing the value here. This is what is called a variable, this $1. We're going to see it a lot more. And I'm changing the meaning of this $1 to whatever this is. So whenever I'm changing this, right now, this means 76. If I change it, this means 146. I'm telling the line to go from the last value, which was 76, to 146 in 500 milliseconds. Now I'm going to go crazy. I'm going to go to like 500 or something. And it's going to take, again, 500 milliseconds. Let's do that. There you go. And back down. Yeah. And it's the same exact concept with the line tilde object, except it's with signal. And signal is actually a lot richer, a lot denser than just these this data as we looked at in the last tutorial. Signal has to do with 48,000 or 44,000 samples per second. So that's a lot more data. So what I'm telling it here is go to 0.078 in 500 milliseconds, but this line tilde object is very smart. It's going to find a value for each sample. So it's divided by 48,000 per second and find each sample the correct number so that it creates a smooth line in that sine wave. So if we look now at the spectroscope and the scope, and I'm going to do the same thing again. You can see, especially in the spectroscope down there, that there are no high frequencies introduced. And we can do the same thing with the frequency now. There won't be any distortion, so we can change the frequency without that weird low rumble that was created in the left-hand side. We can take a listen to that again. That distorted sound. So that's what the line tilde object does. It's feeding a signal into a signal, because remember the cycle tilde is a signal. And you can also change these values, right? As we did over here, you can change this to be 50 milliseconds. And this as well. And then we can see how much quicker it's now. So, right, almost no time. You can go that quick and change the frequency as well. And there's much less delay. But if you make it too small, if you make it 0.5, then you're going to have zipper noise again. I can just for demonstration show you 0.5, and let's do it again. Right, you can see if we zoom out again, you start to get some higher frequencies there. And that's because you get distortion. You always get distortion when you change the amplitude of a waveform, but how much distortion depends on over what amount of time the amplitude is being changed and how much. So bear that in mind, that this is not perfect, but it's close enough that the human ear doesn't notice it, that it doesn't notice the imperfections. And that's it for this video. It was a quick one. I will see you in the next one. Don't forget to like and subscribe if you enjoyed, and take care.